Welcome listeners to the next topic of our discussion, that is your Karst topography, and again this is a part of our discussion in the series of lecture under fundamentals of geology. And like earlier to this topic we have discussed about groundwater and different types of aquifers and how groundwater gets stored and transmitted, and how it is a part of the hydrological cycle. We have seen these things, and based on that, also depending on various factors such as be it your geological formation, be it the amount of recharge and discharge, how this water table is varying from time to time, and leading to that sometime due to excessive discharge, how your cone of depression is becoming bigger and bigger with time, and that may lead to complete depletion of an aquifer, and definitely that will pose a very huge problem in our livelihood. So the next thing that I wanted to discuss is the landforms that are purely made up or purely formed as a result of your groundwater. So the most striking feature, these are one of the most striking feature that are formed as a result of groundwater percolation, infiltration and subsequent dissolution of materials, that is your Karst topography. So first we will be introducing that what a karst is. So a karst is a distinctive landscape formed by the dissolution of soluble rocks such as limestone, dolomite and gypsum. So you can see you are looking at now specific rock type as well as sedimentary in nature, that are susceptible to your both mechanical and chemical weathering, but obviously chemical weathering is the main factor here. So we will be looking into that. So this dissolution occurs primarily through the chemical reaction, like I was mentioning. The main role played by the groundwater is under the action of your chemical weathering between the rock and acidic water, usually rainwater that has absorbed carbon dioxide from the atmosphere, forming a weak carbonic acid. So this carbonic acid is the, you can say, the main significant parameter, the content of the carbonic acid that might lead to the formation of this kind of karst topography. So over the time, this acidic water seeps into fractures, joints in the rock, gradually enlarging them and creating a network of interconnected underground channels, caves, sinkholes and other karst features. The result is a landscape characterized by distinctive surface and subsurface features, including sinkholes, disappearing streams and underground drainage system. So this is the possibly the most beautiful example on earth of the karst topography that you get to see in China. So this process of formation of karst topography is referred to as your karstification or speleogenesis. So this happens, this is a very schematic but nice one, nice representation that how this kind of processes are operating in the subsurface regime. So you have this limestone bed, again that is chemically derived or biochemically derived non-clastic sedimentary rock that is overlain by this topsoil. So now in a period of your rainfall, what is happening that the rainfall is percolating through these fractures and joints that are already present within the top part of your surface, and obviously that carbonic acid that is present in the rainwater will react with the limestone in a, and it will dissolve the limestone by the process of chemical weathering, resulting into the formation of these caverns, and also the caverns will be formed at the subsurface, and on the surface you will get to see some structures like sinkholes. We will be looking into that in detail. So now just to understand the process of karstification, that for example, if you are looking at a locality like this, in the three-dimensional view, you have two sets of joints or three sets of fractures that are present in the locality. So whenever there is a there is an interaction or intersection between the joints and fracture planes, there obviously the percolation, because these are joints and fractures, weak surfaces, or you can say there are some discontinuities that we discussed earlier when we discussed about structural geology. So, so now you have two planes of joint planes like this. So, there will be a space in between the joint planes because they have moved a little bit from one another. So, at these junctions, what will happen, the percolation of the rainwater will be maximum, and the rainwater along with the carbonic acid in it will infiltrate through the soil and directly will affect the limestone or dolomitic horizon that is sitting just beneath the top soil. So, here you can see there is percolation that is going on along this joint planes. Then you have your rainwater along with carbonic acid is percolating through these fractures, and there your dissolution of materials will start to take place. If it is goes on and on, then these you can say locations where there is an orthogonal relationship between these joints or high angle relationship between the fractures, there this kind of holes with subsequent phases of dissolution of material will create this kind of holes in the top part of the soil, leading to the formation of what we refer to as a solution sinkhole or simply sinkhole. So, now if I simply look at a cross sectional view that how these processes are going on, then again if I start with this diagram, then here you can see there is a top layer of soil underlain by this layer of limestone, and you have this groundwater table which is situated at this stage just above or at the margin between the limestone horizon and the top soil. So, now with time, if so definitely if there is groundwater and it is also getting supply of the carbonic acid from the rainwater, so that will start the chemical reaction between the limestone and the carbonic acid that is obviously present in the rainwater, and that is present here under a submerged condition, submerged in terms of groundwater, not directly your surface water is not relevant here. So, we are not talking about submerged under the surface water level, here it is kind of submerged under the water table. So, then the reaction start, for example, at a position like this, and as this dissolution process goes on and on, it will create this kind of you can say caverns or caves, or the materials that are already present here will go into solution and will be eroded away along with the movement. Obviously, it will be a relatively slow movement, but along with the movement of the groundwater. So, the whatever material is going is present in this particular part, that is mainly the limestone that is getting altered under the action of the carbonic acid, is getting you can say simply eroded away from this part. Then with time, if the water table falls down a little bit, in case for a in a dry season when the water level usually drops. So, if the water level is dropping like this and so on and on, now you have a scenario here, again the water level has dropped further, then these caverns get exposed from on the you can say mountain cliffs or some places where you can see a sectional view of the limestone and the topsoil horizon. There you will be able to see these caverns that has formed like this. So, now the water table has dropped quite a lot, and it is just present at some part of the limestone horizon. So, now if I again think of the same process, that eventually after this process, after the dry season during a rainy one, what will happen, again some rainfall will be there, and along with that obviously again carbonic acid will be there. So, it will again dissolute the limestone horizon that is partially present at the top of this limestone horizon. Again the material will go into a solution, and then here you do not have the water table here to you can say now this process that has initiated after a second rainy season, and there you have this carbonic acid supply which is dripping through the soil, and finally your limestone is also going under solution, the upper part of the limestone horizon, and then again it will start to drip. That is how your drip stones form. So, you have this again a sectional view. So, here you can see that, for example, the groundwater level has gone below this level, but still the fractures or joints that are that were present in the horizons, they are still present in the rock horizon till now. So again, these fractures and joints will be utilized by the rainfall along with the carbonic acid, and they will again take the limestone into solution, and then again they will drip like this, forming drip stones, which are the most you can say fabulous structures that you can see in a limestone cave or in a cavern. So again, like I was mentioning this process, so now your water level is just beneath the, you can say, the limestone horizon. So this kind of dripping of the calcium carbonate that will drip due to the action of the carbonic acid like this. So you will get the formation of stalactites from the roof downwards, you will get the formation of stalagmites from floor upwards, and also if one stalagmite is meeting with the other stalagmite, it will give you cave pillars or columns, these kind of fantastic underground structures like this within limestone caves. So now if I look at the whole scenario like this, then obviously you have the soil and just below the soil you have the limestone horizon, this large limestone horizon. Then this is the kind of sinkholes that might form again due to the continuous dissolution of the limestone. So it will finally form this sinkhole. Now beneath again that further deep down there will be this kind of you can say very irregular but very beautiful in nature caves that will be formed, and there you can get this kind of stalactite and stalagmite when finally your water level is beneath that limestone or at the bottom of that limestone horizon. Then only these caves will be exposed, or these pillars will form after the water level has gone down. If it is within in the water level, there will be only, you can say, there will be continuous solution that will simply go on, it will not get deposited at the dripstones or your stalagmites or stalactites. So once the water level falls down further, then only you will get to see this kind of development of your cave pillars or stalactite or stalagmites. One thing here I would like to mention that this lowering of water table, because earlier there was the water table was quite higher. So in these caves, if the water these caves is filled up with water, in that case what will happen, that the water pressure will also support the overlying horizon of the limestone or even the topsoil. So it will support the all the overlying material that are present just above the cave or above the cavern. But if the water table falls down beneath the cave or beneath the cavern at much lower level, then this water pressure will no longer be able to support this. So this might also lead to land subsidence, because there is no more pressure to support, and you have kind of taken all the foundation from the cave. So there is a possibility that your land subsidence might occur along with this kind of formation of sinkholes. So again, just looking at the process of the karstification. So here the solubility of the limestone and presence of calcite is very important, that how far this speleogenesis process will go. Climate, again temperature and moisture, structure of the limestone joint fractures and even the porosity of the rock, mineralogy and lithological content, percentage of clastic and your sparite, micrite and skeletal remains, vegetative cover that also controls the acidity of the groundwater, and your atmospheric carbon dioxide affects the solubility of the carbonate. So, the dissolution of carbonate that takes place, that calcium carbonate dissociates into its constituent ionic components in water, Ca2 plus and your carbonate ion, limestone. Dolomite also get dissociates like your calcium ion, magnesium ion and your bicarbonate ion, and now you have this dissolution process will occur more frequently as a result of the reaction with carbonic acid, formed with the carbon dioxide. So, your CaCO3 plus water and carbon dioxide will give you this bicarbonate ion plus your calcium ion. Similarly, in case of dolomite, when it is combining with water and carbon dioxide, it will also result in the formation of calcium ion, magnesium ion and 4 bicarbonate ions. So, like this reaction or this reaction is, you can see, the background reason for this kind of dissolution of calcium carbonate. Then again, coming back to now the landforms that are related or associated with this, means movement and the chemical weathering processes that are coupled with the groundwater. So, a sinkhole or doline are depression or hole in the ground caused by some form of collapse of the surface layer due to dissolution. So, again and again, if this dissolution progresses, what will happen, like I was mentioning, that with eventually if the water level drops down, then there will be no water to support this kind of hollow region or the cave that got generated due to the dissolution of the limestone. So, resulting into this kind of land subsidence might occur. So, you can see an example of this, a sinkhole formed engulfing the whole house. Right here you have a sinkhole here as well, and here as well a large sinkhole that you can see. But always remember, these sinkholes are actually the surface expression of your karst topography that is present beneath. Obviously, sinkhole is also a part of the karst topography, but these are mainly surface feature, but the rest of the feature is actually within the caves. Then you have this kind of surface landforms related to karst topography as well, that are uvalas, a compound sinkholes made by the enlargement and coalescence of smaller individual sinkholes. There are series of sinkholes like this, you can see here. So, they are referred to as your uvalas. Then polge, also called karst polge or karst field, is a large flat plain found in karstic geological regions of the world, with areas usually in the range of 5 to 400 square kilometer. So, you can see there is a complex network of this kind of karst field. So, the main landforms that are formed with result to this process of your dissolution of limestone or dolomitic horizons, or sometimes gypsum as well. Obviously, these are depicted here in this schematic diagram. You can have this limestone pavement, uvala, doline like sinkholes, polge, again this one. Then you have this cavern where you will get your stalactites, stalagmites, pillars. Then some part, if some part of this karst topography is now your topsoil has been eroded, and the rest of the part apart from the structures that are present within the caves, the rest of the part are eroded, what will happen? It will finally expose the karst towers that are present that were present sometime within some cave or cavern. Then you can also get this kind of karst cones. So, these are the very beautiful karst feature that you can see in China. This one are your karst towers, like the first diagram we have seen, means first field photograph that we have seen. So, this is another field photograph where you can look at the large karst towers. So, the cycle of erosion in a karst topography, it is a cycle of 3 stages. The first is the youthful stage, when your rivers are flowing on the surface, leading to the erosion of impermeable rock, then erosion of the permeable rock, that is, for example, your limestone or gypsum, then chemical weathering under the process of carbonation that will lead to the formation of shallow holes. In the mature stage, what happens, that the dry valleys, because here now your water table in the dry valleys will go down a little bit. So, your holes will try to more number of sinkholes will form. In the old stage, weathering, then removal of the limestone, older more resistant rock left only, that is like this karst towers will only remain when it is in the old stage. So, rivers once again flow over the surface. So, your karst topography will lead to the erosion. Final fate of the karst topography will be that the caverns or caves will with the process of long term of weathering, it will be finally exposed, and some structures like your remnant dripstones in small scale, in large scale some karst towers will remain, and again your rest of the, for example, stream related geomorphic feature will again start to form. So, finally, if I look at the distribution of karst topography, then the large distribution of karst topography you can see in parts of China, some parts of Africa and North America, a few in Australia, and a few more in the European part as well. Very near to this place where I teach, that Banaras Hind University in Varanasi, very near to this place, approximately a drive of around maximum you can say 5 to 6 hours. There is a place known as Chitrakoot. There are also very beautiful this limestone caves where you can go and see directly these cave pillars, the stalactites, stalagmites and other kind of cavern structure or karst topographic structure. Also there are limestone on caves in some parts of your Andaman Island. So, if you get a chance, you can visit these places if you really want to look at the karst topography or the geomorphic landforms formed as a result of the action of groundwater, obviously coupled with the effect of the rainfall. So, here I would like to conclude my discussion on karst topography. Next, we will be moving into a different topic. Thank you.